everyone, so this is the second video for chapter 8. This video will go over the multiple choice questions. As always, if you have any questions, please email me, reach out, and I will answer them so that you are not confused, especially going into the first test. The first question says the marginal product of the fifth unit of labor is, and then we're given a table. I am going to work the table out on a bigger slide just so it's a little bit easier to write on, and then we'll come back and answer this question. So this is the exact same table, just slightly larger. Our first one is units of labor, total product, average product, and marginal product. So for the first row, you're just taking it all the way across because our average product is just 20 divided by 1, which is 20, which means our total product has to be 20. And if our marginal product, when 0 workers is 0, that means this worker added 20. So for our second one, if our marginal product is 30, that means we know that we're going to add 30 to our original 20, and our total product is going to be 50. And then our average product will be 50 divided by 2, which is 25. Next one, our total product is 66, which means from here to here we went up by 16. So our marginal product is 16. So 66 minus 50 gave us 16. And then 66 divided by 3 will give us our average product of 22. For worker 4, our marginal product is 10, which means we are going to add 10 to our total product, which means our total product is going to be 76. And then we're going to have 76 divided by 4 for our average product, which is going to be 19. Next one, we know that our average product, when we have 5 workers, is 16. So 16 times 5 will give us our total product, which is 80. And then our marginal product is from here to here. So 80 minus 76 equals 4. So for worker number 6, we know that we went from 80 to 78, so we went down 2. So our marginal is, oh, whoops. Sorry, guys. This one was 4. This one was negative 2. And then we have, so 78 minus 80 gave us our negative 2. And then for our average product, we're going to have 78 divided by 6, which gives us 13. And then for our last one, our 7th worker, we're going to have an average product of 10. So 10 times the number of workers is going to give us our total. And then our marginal product, which is 78 to 70, we went down by 8, so it's negative 8. So we're going to use this table to fill in this question. And we're going to be looking at this row, which is this row. And we want to know what the marginal product of the fifth unit of labor is, which is 4. And then I have the same little table already pasted onto the rest of them. so that we don't have to go through it again and again. Diminishing returns begins with, to look at our diminishing returns, we're looking at marginal product. And we want to see when it stops increasing. So we're going to look at this column. And we are going to see, sorry about that, guys, from 20 to 30 increases. But then from 30 to 16, it decreases. From 16 to 10, it decreases. From 10 to 4, it decreases. From 4 to -2, it decreases. And from -2 to -8, it decreases. So we can actually see that it starts decreasing with this third unit of labor. That's the first time that our arrow starts to be orange. Marginal product of labor is negative. We're going to change colors of our highlighter. But it's negative right here, which is when 6 and 7 units of labor are employed. So our answer is both B and C. Given the table below, if capital is fixed at 1 unit, diminishing returns begins with. So we need to focus on this column. And just because I cannot write small enough, we're going to bring it up here. So 80 and then 180, 270, 340, 390, 410. And from 80 to 180 is 100. From 180 to 270, it's 90. From 270 to 340, it's 70. From 340 to 390, it's 50. From 390 to 410, it's 20. So from here to here, it increased. But from here to here, it decreased. Meaning that our diminishing returns set in with our third unit of labor. If labor is fixed at 5 units, how much does the second unit of capital add to the total output? So this time we're fixed at 5. So we're looking at the yellow row. So this is our row brought up to the top. From here to here, we did plus 100 because our marginal product of capital was plus 100. If average product is increasing, the marginal product must be greater than average product. That's just a definition. If marginal is bigger, then average will be increasing. It doesn't matter what we're looking at, if we're looking at costs, if we're looking at products of labor, regardless. So the next one says, suppose you run a pizza shop and currently have 2 employees. If you hire a 3rd employee, your output per day rises from 55 to 65. So that means our output with 2 workers is 55. Our output with 3 workers is 65. If you hire a 4th employee, output rises to 80 per day. A 5th and 6th employee would cause output to rise to 90 and 95 per day, respectively. So it wants to know about our diminishing returns. If we look at our answer choices, so we need to calculate our marginal product of labor. So our first one, we're not actually sure since we don't know what came before it. But from 55 to 65, we went up by 10. 65 to 80, we went up by 15. 80 to 90, 10. 90 to 95, 5. So from 10 to 15 is increasing. And from 15 to 10, it's decreasing. Our number started getting smaller, which means that it starts with the hiring of the 5th worker. Use the following table if labor is fixed at 3 units. How much does the 2nd unit of capital add to total output? So we're looking at this. So from 150 to 360, so 360 minus 150 is 210. So our answer is C. If capital is fixed at 3 units, how much does the 4th unit of labor add to total output? So this is our marginal product of labor. So 48, 40, 34, 26, 16. Our 4th unit of labor is right here. It's 26, so none of the above. If a firm is producing a given level of output in a technically efficient manner, then it must be the case that this output level is the most that can be produced with the given level of inputs. That's just definition. Diminishing returns refers to the decrease in marginal product that results from increases in the variable input. The key from this is to always look at the marginals. Whether that's marginal product of capital, marginal product of labor, doesn't matter. Given the table below, as the number of workers increases from 10 to 15, output per worker does blank. So our average product is 28, and we have 5 workers. So 5 times 28 is going to give us 140. It's going to go here, which means our marginal product is going to be change in quantity over change in labor. So 140 over 5, which is 28. if we know our marginal product is 10 when there's, our marginal product is 30 when there's 10 workers, then we know that 30 equals our change in quantity over our change in labor. Which is something over 5. So if we solve for our change in Q, we're going to get that our change in Q was 150. So 150 plus 140 gives us 290 as our total product. And then 290 divided by 10 gives us 29. So our next one, it tells us our total product is 420. So 420 divided by 15 gives us 28. To find our marginal product, we're going to need to determine how much output increased for these 5 workers. So we're going to have 420 minus 290, which is 130. So our marginal product of labor is 130 over 5, which is 26. So our output per worker decreases from 30 to 26. Because output per worker means we're focused on our marginal product column. And here it is in slightly better writing, just so that you can see it. Again, the slides will be posted on Canvas, Blackboard, so if you need to look at them, hopefully the math with the numbers and such will help as well. Given the table below, what is the total fixed cost when 400 units of output are produced? Total fixed costs never changed. So all we have to do is figure out this first time, right here. Total costs are fixed cost plus variable costs, which means if our total cost is 560 plus our fixed costs plus 60, that means that our fixed is $500, because there will be a 500 right here, but you don't have to fill in the rest of the table unless you just really want to. Next one says, suppose that the firm's only variable input is labor. When 50 workers are used, the average product of labor is 50 and the marginal product of labor is 75. The wage rate is 80 and the total cost of fixed input is 500. What is average variable cost? So we know that there's 50 workers. Which means we know that our average product of labor is 50. So our labor times change in quantity, times quantity divided by labor is going to give us quantity. So 50 times 50 gives us 2,500 as our Q. We know our wage rate is 80. So 80 times 50 gives us 4,000 units of whatever we're producing. Or $4,000 as our total variable cost, sorry. Our total units we're producing is 2,500. So our average variable cost is our total variable cost divided by quantity. So 4,000 divided by 2,500 equals $1.60. What is the marginal cost? So marginal cost, this is the exact same problem. Marginal cost is change in total cost divided by change in quantity. So 80 divided by 75 is 1.066, which is none of the above. Average total cost. These two, it depends. If marginal is greater than average, then our average increases, just like we talked about earlier. 17 says a firm is currently producing 10 units of output. Marginal cost is $24. Average total cost is $6 at this level of output. Average total cost at 9 units of output is. So when our quantity is 10, our marginal cost is 24. And our average total cost is 6. Then using this, we know that our average total cost is equal to total cost divided by quantity. So 6 equals total cost divided by 10, which means our total cost is 60 if Q equals 10. We know our marginal cost was 24. So if we do 60 minus 24, we find that our total cost at 9 units was $36. So the average total cost of 9 units was be 36 divided by 9, which is 4. Some of these questions, it kind of feels like it's a puzzle, trying to figure out what they're giving you, what they're asking for. Refer to figure 1. Given this, when does diminishing returns set in? And the way we're looking for this is we want to see when does our marginal product curve stop increasing? So our marginal product curve is this one, and it stops increasing right there, which my dot was pretty close to the top. So the 6th unit of labor, which we see at the bottom. Apparently this is a naughty race, but that's all right. Refer to figure 1. The price of labor is $60 per unit. When the firm uses 6 units of labor, what is marginal cost? So our marginal product of labor is 12 when we're employing 6 units, which we see from our y-axis. So marginal cost equals change in total cost over change in quantity. So 6 divided by 12 is 5. So our answer is 5. Question 20 says, when the firm uses 4 units of labor, what is average variable cost? So 6, that was not a straight line. Let's try that again. Goodness. We want 4 units. I'm so sorry. So we know that our average product of labor is quantity divided by labor. We know that our average product is 6 when our quantity is unknown and our labor is 4, which means our quantity is 24. So our variable cost is going to be the price of our labor times the number of units we're using. So 60 times 4, which is 240. And our average variable cost will be variable cost divided by quantity, which is 240 divided by 24, which is 10. So question 21 says refer to figure 2, and the figure below, same idea, doesn't really matter. The wage rate is $600 and total fixed cost is $15,000. How much output does the firm produce when average variable cost is at its minimum? So when average variable cost is at its minimum, this means that, or this occurs at the maximum of the average product curve. So if we look at our average product curve down here, you see that our maximum is right here. And if we go down, you see that that's 30. And we go across, you see that the average and marginal product for this point is 160. So we're using 30 laborers, which means we're using 30 workers, 30 hours, whatever. And 160 is our average product per worker. So 30 times 160 is 4,800, which is E. Next one says, when is average variable cost, what is average variable cost at its minimum? So again, we already know that we're looking at the same point. We care about when our average product curve is at the max. So we know we're at 30 and 160. So 30 units of labor $160 is our output per labor. or our average product of labor. And then it wants to know the average variable cost. So average variable cost is going to be our cost for labor divided by the quantity that we're producing. So in order to do this, we need to know our quantity, and our quantity is going to be labor times our average product of labor. Because if you remember, this is L times Q over L. So those L's cancel, and we're left with Q. So that's going to be 30 times 160, just 4,800. So that's going to be on the bottom. And then we know our wage rate is 600. So our total cost for labor is going to be 600 in wages times 30 units of labor, which is going to give us 18,000. So 18,000 is going to go on top. 18,000 divided by 4,800 gives us 375. 23 says, refer to the following. Ford built 18 vehicles per auto employee in North America last year, where GM could only manage 12. In comparison with Ford, GM had, and our answer is lower average variable cost. And the reason we know that is because average variable cost is defined as variable cost divided by quantity. So for Ford, it's going to be variable cost divided by 18. While for GM, it's going to be variable cost divided by 12. If you divide by a bigger number, your answer will be smaller, so lower average variable cost. 24 says, refer to figure 3, assume labor, the only variable input of a firm, has the product curve shown below. The price of labor is $1,000 per unit, so that's our wage rate. At minimum average variable cost, the firm employs how many units of labor, and it's reached at how many units of output. So we care about minimum average variable cost. Which means we care about the max of our average product curve. So we care about right here. And if we go down, we see that they are using 450 units of labor. And the average product of those 450 units of labor is 2,025. So we're employing 450 units. And then labor times average product of labor will give us our quantity, because that's labor times quantity over labor, which gives us just quantity. So 450 times 25 will give us our quantity. and 450 oh, that's it. I'm trying to make it more complicated, sorry guys. Which means that our quantity is 911,250. Which is none of the above. The only answer choice that could have been was this one. So if you're doing a question like this and you only have one answer choice, take the 30 seconds to put it in your calculator and make sure that that's right. The price of labor at its minimum, this is the exact same problem as we literally just did, except now it wants to know the average variable cost is. So we know that we're caring about this point from the previous problem. So we know that our quantity is found by 450 times 2025. We know that our variable cost is going to be found by the number of laborers or the number of workers times our cost, which is 1,000. So our variable cost is going to be 450 times 1,000. And our average variable cost is defined as variable cost divided by quantity. And you could just multiply these out and then type all of those in to get a decimal point, and that will work fine. But in the event you didn't want to do that, you can also look at it as a really big fraction and see what cancels. These 450s cancel. So we're left with 1,000 over 2025. And then our last one, which apparently did not erase from when I made a typo and had to come back and do it, says refer to figure 3, the only variable, same thing. Except this time it's asking for marginal cost reaches its minimum value at. So we're going to look at our marginal product curve. And we want to look for the max. Our marginal cost reaches its minimum when the marginal product reaches its maximum, which is at 300 units. But then to figure out the output, it's substantially more work to try to use the marginal product curve than the average product curve. So we're going to go down to the average product curve, and when we do that, we see that at the average, they're using 1,800. So 1,800 times 300 will give us our quantity. But we're choosing the 300 because the 300 is at the max of your marginal product curve, which gives us B. As always, if you have any questions, please email me and let me know. I hope you have a great week.